A long time.
Okay. Lesson 27. We are continuing our trip into derivatives. Today's talk is equation of the tangent line and higher order derivatives. So we talk higher order derivatives instead of what we've been finding is the first derivative. We'll find the second derivative, the third derivative, the fourth derivative.
Oh, God.
So, but before we do that, we're going to talk about equation of the tangent line. Okay, so reminder up there, the slope of the line tangent to a curve at a designated value of x can be found by evaluating the derivative at that value of x. Because what is the derivative? Slope of the tangent line. So if the derivative is the slope of the tangent line, and we have a specific point for that of where they meet, or what, where we're trying to find, we can use the derivative. Okay? So, let's look at example 1, and I'll do a better job of explaining what I mean here in case you're not sure. Y equals x squared minus 4x plus 3. So that is our given function. We're being asked to find dy dx evaluated at 3. Okay? So we're being asked to find dy dx when x equals 3. So right here, this y equals, here's what I would say. Think of that y equals as your f of x. That is your function. If that is my function, I'm being asked to find the derivative at 3. Which means I think of it as we're being asked to find f prime of 3. Does that make sense?
Yes, ma'am.
Okay, let's do it. When we write y, the derivative of y, a couple different ways you can write it, but right here they're talking about it as dy dx. Derivative of x squared, 2x, minus derivative of minus 4x, minus 4, plus derivative of 3, 0. Are we okay with that? I'm just always taking that exponent out front and multiplying by it and subtracting 1 from the exponent. Now, that's dy dx. We're asked to find dy dx evaluated at 3. So that means we're doing what? Plugging the 3 in. So, 2 times 3 minus 4 is 2. Because 6 minus 4 is 2. So, what this is telling me, on the equation, y equals x squared minus 4x plus 3, minus 4x plus 3, on that equation, when x equals 3, the slope is 2. That's what that is saying. When x equals 3, my slope is 2. And I might even write that in there. When x equals 3, the slope is 2. Okay. So hang on to that thought, because that thought is going to continue as we're asked in the next problem to find the equation of the line tangent to the graph. Okay, so find the equation of the line tangent to the graph of y equals x squared minus 4x plus 3 when x equals 3. So, equation. Okay. Same thing as the first thing we did. Okay. In that when we talk about the slope, we kind of already know, and I'm debating, do I want to put it back on here? Okay, so we know slope then, yes? What else are we going to have to know to write an equation? Okay, a y-intercept is what Mallory said. What'd you say? Okay. Okay. In other words, and although technically it wouldn't have to be a y-intercept, a point of some sort, right? What do we already have here? We have the slope from above, and we have an x-coordinate, yes? So, if the x-coordinate is 3, what is the equivalent y-coordinate? Y0. Okay. It is. How did you know that, I guess, is where I'm going here. You kind of guessed.
You plug it into the equation.
Okay. What I was looking for is take 3 and plug it into the original equation, and that will give you an ordered pair.
You get 9 minus 12 plus 3.
That's what I was looking
I
for.
just kind of looked at it as like the line is x equals 3.
Yeah. Like if I do
That way something wrong.
y equals x squared minus 4x plus 3, so y equals 3 squared minus 4 times 3 plus 3. That's the math I was looking for. So y equals 9 minus 12 plus 3. 9 minus 12 is negative 3 plus 3, 0. And so by plugging in 3 here, what we got, and I'm going to write it out, is a point on the line at x equals 3 is the ordered pair 3, 0. Okay, that's what that is. And our work is by plugging the 3 in there. Now, we have a point on the line, yes? 3, 0. It's not the y-intercept, but we can make that, we just need a point to get us started. I'm going to go ahead and write it out here that the slope came from doing the 2x minus 4 evaluated at 3. So 2 times 3 minus 4. So dy dx evaluated at 3 was, I just wrote 6, but I don't really mean 6. I mean 6 minus 4, which is 2. And this is our slope when x equals 3. What do I need to do to finish this up to write my equation?
Put in the y minus
Okay. Nathan's using point slope. Y minus y1 equals m times x minus x1.
Yep.
Your other option is you could use y equals mx plus b, right? Fill in your x, y, and m and find a b value that way. I don't do that as much anymore. I don't know, I just don't like it as much anymore. So y minus y1 equals m times x minus x1. I'm just going to write it in on this first one. So y minus 0 equals 2 times x minus 3. And what do we have here? Y equals 2x minus 6. That is the equation of the line tangent to the graph when x equals 3. Okay, so find the slope at that point, find the point, put it into an equation. That's the gist of what all needs done. Questions? Think you can do the next one then? Again, we're being asked to find the equation of the line tangent to y equals sine x when x equals pi over 6. Where would you like to start? Find the slope, he says. So in order to find the slope, I need to find the derivative, dy over dx. What is the derivative of sine x? Cosine x. We learned that yesterday, right? So if the derivative of sine x is cosine x, then what do I do? Okay, once you have the derivative, plug that x value in. So we're doing dy dx evaluated at pi over 6, which means we're finding cosine of pi over 6. Before anyone says it out loud, everyone got it in their brains? It's a good kind of self-test without me giving any instruction, without you guys saying them out loud. Have you visualized it? What is cosine of pi over 6? No? It's got to be the other one then, right? Square root of 3 over 2. So here's my brain working. Pi over 6 is the smaller fraction in our chart, right? It's 30 degrees. And in that 30 degree row, sine comes first with 1/2, and then cosine is the next one. Okay, so what is that square root of 3 over 2? That is my slope at x equals pi over 6. Okay, we got the slope. What else? We need a point. Okay, plug the given x value into the original equation to get the point. So in other words, in order to have a point on the line at x equals pi over 6, I know my ordered pair is going to be pi over 6, comma, something. Like, that's what I know without doing anything on this problem. Notice Daryl specifically said use the original. We're not doing the derivative because that provides us the slope, not the other ordered pair. So, if y is sine x, now we're being asked for the sine of pi over 6. What is the sine of pi over 6? There's your 1/2, right? Notice he had confidence this time, like, okay, I got this one. Yep. Okay. Here we go. Y minus 1/2 equals square root of 3 over 2 times parentheses x minus pi over 6. That's a good description. Gross. Okay. So y minus 1/2 square root of 3 over 2 times x is square root of 3 over 2 times x minus square root of 3 over 2 times pi over 6. How do you feel if I say pi square root of 3 over 12? And then I need to add over the 1/2.
Yeah.
So y equals square root of 3 over 2x minus pi radical 3 over 12 plus 1/2. It might not be beautiful, but It is an exact answer. So we're going to stop there. Yes, there would be a decimal equivalence, but I don't want it. Okay, you get the hang of that? That is definitely a process we'll keep coming back to this year. Okay? That's definitely an AP exam process. So, one last stab. Find an equation of the line tangent to y equals sine x when x equals 1. Am I going to throw you guys off too much if I start with the point? You guys want to start with the slope? If I start with the point on the line at x equals 1, what do I know about my ordered pair without doing any math? Yeah, 1 comma something. How do I find my something? Okay. Plug in 1 for x in the original equation. So I'm going to do the sine of 1. What is the sine of 1? No. The sine of pi over 2 is 1. But this isn't an inverse. Is 1 of the angles we know? No. So you must use the calculator. Okay? Nathan has calculator out. He's like, do I? Do I?
Should it be in radians?
Okay, so the question is, should it be in radians or degrees? Is there a degree symbol on that one?
No, it says radians.
Since there is no degree label on that one, it is automatically defined as a radians. So get your calculator in radians and do the sine of 1. Okay, so what is the sine of 1 radian? 0.8415 is what I have written down. So my point on my line, my ordered pair, is 1 comma 0.8415. I also need to do my slope. So, if y equals sine x, what is dy dx? Derivative of sine x is cosine x. And then we need to do the derivative evaluated at 1, which means I'm doing cosine of 1. And you probably figured out, if we had to plug in sine of 1 on the calculator, then you have to plug in cosine of 1. What is the cosine of 1? 0.5403. And what is that 0.5403? That is my slope at x equals 1. And again, I get it that you know that now, but I'm writing it down so if you forget it later. Okay, you ready for your equation?
Yes, ma'am.
Y minus 0.8415, and you could do this 2 different ways. It is 0.8415. You could also, where did that 0.8415 come from? Sine of 1. So you could use sine of 1 there as well. And actually, well, you're just going to have to plug it into the calculator eventually anyways, which is why I was debating. I mean, if you want to put sine of 1 here temporarily, you can. Okay, but it is going to be the same as 0.8415 equals, what's my slope? It's the cosine 1 which is that 0.5403, times x minus 1. Okay. It's y minus the 0.8415 or the sine 1 equals, oh, that's why I did it, I think. Because here, if you keep it as sines and cosines, then you can add them together that way. So, but if I change this to decimals, which I already did, 0.5403x minus 0.5403. And that went off the paper. So, y equals, did you get it yet? 0.5403x, and then it's minus 0.5403 plus 0.8415. What does that come up to be? 0.3012. So yeah, whether you work with decimals, whether you work with sine 1, cosine 1, it all is the same idea. Okay, that is probably, honestly, the tougher thing today, I think. And if you didn't think that was tough, then I don't think you'll think anything's tough today. Okay, before I flip to the back, notice what it says down there at the bottom. Higher order derivatives. What is our notation for the derivative that we've used in this form? Just a single little mark, which we read as prime. And so f prime of x stands for what you have known up to today as the derivative. Well, it's actually the first derivative. If you see a double prime, that means the second derivative. If you see a triple prime, that means the third derivative. 4 prime marks would be fourth derivative, so on and so forth. Okay, so you can take multiple derivatives. The key is, the first derivative, you know how to get there, right? To do the second derivative, the derivative of the derivative. To do the third derivative, the derivative of the derivative of the derivative. You just keep repeating the derivatives.
That's tedious.
You're just doing derivative over and over.
So yes.
I don't think so, but sure. If you want to call it tedious, you will.
Term over and over is
Okay, so that's the tedious part.
The definition of tedious.
Okay, so in this one, let y equals 3u to the 5th. And it's saying find d squared y over du squared evaluated at 2. What do you think that d squared y over du squared is asking us to find? This is notation for the second derivative. Okay? That is notation for the second derivative. And then we're going to be evaluating at 2. Now notice they use dy du. dy on top because my equation is y equals. Du on bottom because my equation is in terms of u. Okay? You cannot jump just straight to the second derivative. You need to take it in steps. So first derivative means I'm just finding dy du. What is dy du?
15u to the 4th.
Mallory says 15u to the 4th. Yes? Because 5 times 3 is 15. Subtract 1 and it becomes 15u to the 4th. That's your first derivative. So now, second derivative, which means I'm finding d squared y over du squared is my notation. So now we're doing the derivative on 15u to the 4th. 60 u to the third. Because 4 times 15 is 60, subtract 1. And what did they ask me to find? 1x equal, or when u equals 2. So out of habit, x equals. So we're finding d squared y over du squared evaluated at 2. So 60 times 2 to the third. What is 60 times 2 to the third? 2 to the third is 8. 8 times 6 is 48. Tack on a 0. 480. That wasn't horrible, was it?
Nope. That was simple math.
You need a calculator and both fail.
Period, Daryl. I'm proud of you.
I'm still working on getting that minute 27.
Have you been practicing?
I got,
Uh-oh.
the fastest I got was like 2 minutes and 15 seconds.
Mine was still faster. My first try.
I was doing government, so I was a
I
little distracted.
know.
Okay, so last example. Let f of x be 1 over x squared. Find, can you read what that is? That is 3. So we want the third derivative evaluated at 2. Let's start with, in order to take derivatives, how should I rewrite f of x? Okay, right. You can't take the derivative of 1 over x squared as is. Move x to the second, up from the denominator. This is x to the negative 2. So I need f prime of x, first derivative.
Negative 2x minus 3. Well, that's the power. Yeah.
Negative 2,
Minus
x
3.
to the negative third. Because you said multiply the negative 2 and subtract 1. Now, I'm just going to leave it in that form because I'm taking yet another derivative. Now I want f double prime, or second derivative.
6x to the negative 4.
Negative 3 times negative 2 is 6. X to the negative fourth when you subtract 1. F triple prime, or in other words, the third derivative.
Negative 24x.
Negative 24, x to the negative fifth. Negative 4 times 6 is negative 24. Subtract
We
1.
could do that all day.
We're at negative 5. You could do this all day.
I would rather not.
We're going to stop here.
Is there any life hack
Now,
you can teach us?
what is another way to write this? Okay, to get that negative exponent out of there, we can move that part to the denominator. The negative 24 stays on top. So this could be written as negative 24 over x to the fifth. And I did that because, what are we being asked to find? F triple prime evaluated at 2. Which to me, when I have to go to evaluate, it's easier to evaluate without negative exponents. So negative 24 over 2 to the fifth. So negative 24 over, what's 2 to the fifth? Nope.
Whoa.
That'd be 2 to the ninth.
Negative 3/4.
So what is 2 to the fifth? Yep, there we go. 32. No, 16 times 16 is 256. Okay. Anyways, negative 24 over 32 then reduces to negative 3/4. Okay.
It's 2 to the 8.
Oh, it's 2 to the 8th?
256 is
Oh, yeah. Well, here's what I know. When Nathan said 512, I know 2 to the 10th is 1024. And so the one before that, divided by 2, is 512. So thus 2 to the 9th.
At least you got one of them.
So,
You don't know.
Okay. That is our
You're wrong, but you're not.
higher derivatives.
You are indeed wrong. But
But you were close. Extra effort.
Go ahead and get your homework out.